to Sega Tech Chats.
Robots are gaining many new capabilities, and while the humanoid robots get attention for doing backflips and parkour, the less glamorous industrial and service robots are providing more meaningful functionality. If we add some AI and it leads to the robot apocalypse, you can start the finger pointing with Kai Lee from Meanwell and Scott Phillips from Sager. They're here to talk about innovations and power solutions for robotics applications, and hopefully they'll tell us about some secret kill switch in case we ever need it. Welcome to Sager Tech Chats. Kai, let's start off with how you look at robots in a general sense.
There are many types of robots, and the robots can be generally categorized into many different types of functions and features and types of services they provide. So for the product categorizations, we are separating them into industrial robots and service robots. And for the industrial robots, they typically serve the manufacturing sectors, and they're usually mounted in a fixed location and perform repetitive tasks. And they are usually only designed to perform particular tasks or programmed to do a certain tasks. And for the service robots, they're a bit more flexible, and they are typically designed to perform useful tasks for humans, and they're not limited just to industrial settings like the production line. And they're able to perform various tasks in different environments, and they're often mobile. So as a result, they're more difficult to design, implement, and maintain.
And what do you look at when powering these different types of robots?
So robotic arms is a very common types of industrial robots, and they are also known as articulated robots. And within these robotic arms, the motion are usually driven by various types of motors. So there are servo motors and stepper motors are very commonly used. So servo motors offer high torque, high speed, and they're usually lower in price, but they're less accurate. Whereas stepper motors are able to offer more accurate positioning and speed control. And so this also requires more fine-tuned and more careful control of the power to the motors.
Kai, robotic customers are using oversized power supplies and robotic arms that have DC motors because of high inrush currents and high torque requirements. Can Meanwell provide a better power supply solution to handle these high inrush currents?
Of course. So we want to first begin by discussing one of our latest power supplies that's suitable for robotic applications, and that's the HRP-N3 product family. So the HRP N3 product family was developed to support these kind of high peak current, high peak power draws by the motors that's within these robots. So the HRP N3 will have 150 watt, 300 watt, 600 watt solutions, but they are actually designed to support up to 350% peak power capability. And they come with the constant current limiting feature, which is very important for driving a lot of the motorized applications. So for example, when a motor is during normal operation, it may only need about 600 watts of power draw. However, at the startup, it can be 1200 watt or even higher. However, with the HRP-N3 family, with the peak power capability, the 600 watt power supply is able to sustain that sudden power draw at the beginning. So this results in a reduction of cost for the power supplies, and also saves a lot of space for the system design engineers. So another product series that's suitable for these kind of robotic applications is the UHP product family. So we're talking about the UHP-1000, 1500, and 2500. So the main benefit of the UHP is that it has fanless design, and they support multiple cooling methods. And they also spot the constant current limiting feature. Again, when the motor is running, when you start up the motor, the constant current limiting feature will allow the power supply to sustain the current and not shut down. So the multiple cooling methods for the UHP family includes conduction cooled by base plate, and also forced air cooling, and then water cooled. And we're implementing this kind of design to be able to cool the power supplies more efficiently and utilize existing water cooling methods to be able to integrate the power supplies into their systems at lower cost and more efficiently. So here's a quick example of one of our customers that's using water-cooled torch on the welding robots. The same cooling system can be used to cool the power supply and the welding robot. So another power consideration for these articulated robots are regenerative power. And by utilizing regenerative power from the motors, we're able to achieve energy saving. And sometimes the regenerative power from the motors can also cause headaches to the power supply system design engineers. And the conventional robotic arms, they typically also need to add on regenerative resistor unit to help dissipate the power that is coming from the motor when it's stopping a motion or suddenly braking. And if it's without those resistors, so it may cause back EMF to shut down the power supplies or cause issues upstream to the power chain, right? But if the power supply, if the robotic arms is designed with the regenerative function in mind, we are able to return some of the electric power back to the AC grid and get rid of the regenerative force at the same time. So that brings us to the bidirectional power supply that Meanwhile offers, which is the BIC-2200. So it is a bidirectional power supply that is able to convert AC to DC and then also convert DC to AC back into the grid. And this allows energy recycling with very high efficiency. So the unit is fully digital control, and it supports CAN-bus digital communication protocol. And multiple units can be also connected in parallel to support those larger robotic applications up to 11 kilowatts. And of course, the unit has to feed back into the AC grid during its inverting operation mode. It's designed with ultra-low total harmonic distortion of less than 5%, so that won't cause any issues or noises to the other devices that's connected on the AC line. And the unit comes with both a automatic operation mode for the AC to DC and DC to AC operation, as well as a forced or controlled mode that is on the CAN-bus model only. So for the automatic detection mode, the BIC-2200 will detect the DC voltage if the voltage on the output side is higher than its output voltage set point. It will go into the DC to AC inversion mode. But if there's no voltage on the output side or low voltage on the DC side, it would just be the normal AC to DC power supply. So in the scenario of powering a robotic arm, during the normal operation, of course, it will take power from AC and drive the motor. And then when the robotic arm is suddenly braking or they're doing a falling down motion, a sudden high voltage will appear on the BIC-2200 output side because of the motor characteristics, the back EMF. And the BIC-2200 will be able to switch quickly into the regenerative mode, which is the DC to AC mode, and then dissipate that force back into the AC grid. And of course, if the customers, their system, they don't want to rely solely on the automatic mode, there's also a programmable bidirectional mode, which uses the control logic by the CAN bus. So customers can pass a CAN bus command to tell the unit which mode they want the system to operate in. All right, and that sums it up for the industrial robots. So now let's talk about the service robots and the suitable power solutions that we have prepared for them. Automated non-stationary robots is a common type for service robots. So they are typically integrated with batteries, and they require chargers. And they usually work with direct chargers that support two-stage battery charging, and also indirect charge by system controllers that handle the charging, the BMS functions. And they usually take constant voltage power supplies with constant current limiting as its operating protection mode. And for these robots, the manufacturers usually work to design both portable or stationary charger solutions. So the portable will be for, say, plug and play and rescue operations. If the robot is out of battery, stuck somewhere, then they need the portable charger to charge it. And then during the normal use, say in a warehouse setting, they have dedicated stationary charger locations or charging docks for these robots to return to and get charged.
Kai, the need for battery chargers and power supplies exist in many of the warehouse robots being designed. Does Meanwhile offer any solutions that incorporate a single unit that can do both?
Yes, I'm glad you asked. So for our latest generation of the charger, the stationary chargers, the MPB and MPP series products, we actually have the dedicated power supply plus charger model that is called the MPP series, and it covers 450 watt to 1700 watt application. So for the MPP, it can be configured by the user on the fly as either a charger or a power supply. And also together in the same product family, we have the MPB, which comes in both basic models that's lower power that just performs the dedicated charging curve, or the intelligent version that's higher power, 450 watt and above until 1700 watt charger that is able to be programmed and also comes with a new auto sensing function that can work for very wide range of lithium ion batteries. So for example, for a 12 volt model, it's able to support battery charging voltage range of 10.5 to 21 volt. So for the higher voltage models, similarly, it supports this kind of 2 to 1, very wide range of charging operation. So the MPB and MPP series, they are a newer product family that replaces the older generation of products. And one of the main features that when we design these, we design them to be as user friendly as possible. So we integrate a lot of the features into the power supply, the charger's faceplate. So this includes the 3-stage to 2-stage charging switch, so the user can quickly adjust the charging curve based on what type of batteries that are used. Because for lead acid, they prefer 3-stage charging, but for lithium ion, they have to use the 2-stage charging that comes with the chargers. And the V out and I out, the voltage, the charging voltage and charging current can be easily adjustable on this model as well, just from the built-in potentiometer. And I also do want to mention that for the 120 to 360 watt models, the smaller power models, we've designed them to be more flexible. So we offer 3 different connector types off the shelf for the users to choose from. So we have the standard DIN connectors or the Anderson connectors, as well as terminal blocks for customers to directly wire to. And for the 450 watt and plus models, because they're for higher power applications, that's typically not suitable for direct plug and play with the connectors. Then we only offer the terminal block versions for the higher power models. And a quick example of the MPB application, one of our customers, they're using the MPB 360-24, so that's the 360 watt charger, 24 volt model, to charge a 24 volt battery that's built inside of a mobile car lift. And this car lift design is actually intended to be wireless. So this is because for the application, for the environment that it's usually used in, the end users don't want any AC cables or wiring around the car lifts when they're working on the cars, because that creates a hazard at the workplace. So they rely on chargers to charge the batteries and have the lift to operate off of the battery. And another example is for a portable charger for AMR. So these are autonomous mobile robots, and they perform various functions such as building inspections or maintenance of the facility. So the MPV product series, as the both portable and stationary charger, they are able to be plugged quickly into the wall and charge the robots as needed. Another series of products I want to talk about that is very suitable for the service robot applications would be the HEP product family. And the HEP product family, for the 1000 watt, we actually designed a charger variant that as well, and it can run charging curves. So it's able to support flexible charging curve adjustment. And what's unique about the HEP product family is that it is IP rated, IP65 or IP67, and it comes with the cables for quick plug and connections to the end user applications. So similarly, we also have a higher power variant, the HEP 2300, which also is designed for harsh environment application. It is slightly bulkier than the HEP-1000, but it's able to support multiple communication protocols. So we offer all these options for the customers to choose from CAN bus, PM bus, and Modbus. And the charging curve is also adjustable. And we offer both the terminal wiring and harness connector types for the 55-volt model. And there are also higher voltage models for robots or other applications that uses higher voltage batteries up to 280 volt DC.
Kai, does Meanwhile offer a way for customers to program current and voltage characteristics into their chargers? And what protocol is being used?
All right, yeah. So I talk about we have the CAN bus, PM bus, and Modbus controls that customers can directly interface and send commands to adjust both the charging voltage and charging current. Meanwhile, we'll provide the list of commands that are usable and instructions for customers to do so. But for the less tech-savvy customers or customers that want a direct interface, we offer the SBP-001, which is our intelligent battery charger programmer. And it offers a flexible charging curve adjustment by connecting the power supply unit, the charger unit, to a personal computer. And meanwhile, we also offer a programming software that are compatible with the SBP-001 unit. So the users are able to, on the graphic user interface, they're able to adjust the voltage settings and the current settings in a more visual manner. And of course, for the customers, they can also send PM bus and CAN bus commands via the SBP-001 directly to the charger units as well to program them. So we talk about the stationary chargers and portable chargers, and so the HEP unit that we covered earlier, they can be designed into the portable charging kit for one of our customers, and actually they designed it into like more like a suitcase design, and that goes along with the robots. So when the robot is needed to be rescued or charged in the field, the operator will have this suitcase as a charger and just carry them around, and then it has all the cables and different cable lanes inside that will be able to easily mount the charger in any setting or environment. At the same time, the HEP chargers, they can also be used inside of the stationary charging stations. Benefit again, the HEP is designed for harsh environment, so very minimal dust or moisture proof design features is needed when the system design engineer is designing these charging docks. So the charging docks are usually mounted in a corner at the warehouse or at the factory, and then these AMRs or AGVs will just be programmed to return to them and charge when they are low on battery. So we are pretty limited by the power ratings on the HEP product family, only up to 2300 watt. But we do also offer more flexible and higher power solutions for customers that are designing higher power charging docks, or as they call it, quick charging docks, right? Fast charging. And that includes our rack mount power supplies and charger series. So we have the 1600 watt RPB 1600 and also the RCB 1600 that comes both in standalone, like an enclosed charger, enclosed power supply, as well as a rack mounted power supply. So same as the 3200 watt variant as well. So both of these are able to mount into their respective 1U height 19-inch racks for a lot of scalability and expandability for different power level operation. So just to put into perspective, the 3200 watt model actually supports up to 25,600 watt operation in a 2-rack configuration. And if the customers need more power for some reason, they can always add more racks to increase the maximum power capacity. And with the RPB 1600 and DBU 3200 series, they also come with the programmable charging curves, either via the aforementioned SBP-001 or the CAN bus or PM bus communication protocols that's supported by the model that is being used. So a quick application example for the RPB-1600 is a charging station for a automated mobile robot. This is a relatively bigger robot, and it's using a 100 amp hour battery for its long lifetime. So the customer needed a more powerful charger to handle that. So that's why the RPB-1600 was chosen over something like the MPB, which is more suitable for lower power and more mobile charging applications. And another example inside a warehouse setting is a charging station for AGV that was using a 150 amp hour lithium-ion battery. So the DBU-3200 was used in this case to provide the quicker charging capabilities to the robot. So that concludes our power solutions discussion for the robots today. And as we have covered, there are different types of industrial and service robots that all require different power supplies or different chargers to work with them. So hope it was informational for you, and you've learned something regarding the power supplies and chargers for robots today.
Those are some great technologies from Meanwell, Kai. I appreciate your time and attention. Thanks very much.
Thank you both. And once again, that's Kai Lee from Meanwell and Scott Phillips from Sager Electronics. If you'd like to learn more about Meanwell Power Solutions for robotics applications, click the links in the description or visit Sager.com. And subscribe to our channel to make sure you catch the next episode of Sager Tech Chats.